let's see. And then whenever this comes up, we'll start talking about it. There we go. Let's go. Student. Hello? The dog is acting up. No, you're all right. I got you. All right, so I'm going to just sort of step through some of these problems. Some of them may just explain a little bit, but I'm just going to go through most of these if it'll come up. There it comes. All right, I think question one, 3 zeros of a fourth degree polynomial. So make sure we understand this, that whatever the degree of the polynomial is tells us how many zeros there are, combined, real, and imaginary. And then this one tells us it's a fourth degree polynomial, and then it gives us 3 of the zeros. Well, anytime we have an imaginary zero, we know imaginary zeros come in pairs. So the conjugates, the pairs are conjugates. So if 2i is a 0, negative 2i has a 0. So that's where that first one comes through. I don't think we had too many problems with that. Problem 2. It says the function x squared plus 6 has the indicated zeros. It gives you the 2 zeros, which are both imaginary. They're conjugates, negative square root of 6i and square root of 6i. Be sure you understand that I is not inside the square root. It is outside of the square root. Let me see if I can make that any larger up there. It's not. So this is just stepping for how to solve for it by isolating the x squared and taking the square root of both sides. I think we're good there. Subtract 6, we get negative 6. Take the square root, plus or minus the square root of negative 6. The 6 won't simplify, but the square root of the negative 1 is I, so that's where we get plus. I don't know why that doesn't show up. But that's where we get negative square root of 6i and square root of 6i with the I on the outside. So let's go to the next problem. This one was just looking at the graph and seeing where it crosses the x-axis. I don't think I need to go over that. All right, so consider the following function and find all the zeros of the function. Okay, so let's step through this one. Okay, so where did my annotate go? All right, so really the rest of this is we are either finding zeros or factors. All right, zeros, real zeros are where it crosses the x-axis. Imaginary zeros we have to find algebraically because we can't find them. So what we have here is x squared, in case we can't see it, f of x equals x squared plus 6x plus 2. All right. So if it is a quadratic, which what we're trying to do in most of these is get it to where we have a quadratic in the problem, because we know how to handle a quadratic. We can either factor it and set each factor equal to 0, or we can use a quadratic formula. All right, as I look at this, if I wanted to try to factor it, I would have x, and I would have to have factors of 2 that added to positive 6, and there are none, right? So that tells me this is not going to factor. So what I'm going to do is I'm going to back out of that, and I'm going to go to my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? And that's going to give me my two x's from this quadratic, my two zeros, okay? Now, just off to the side, okay, let's look at something else. If, let's say we were able to factor it, I just want us to clear up, make sure we know what we're doing. X squared plus 4x plus 3. So let's say I had this quadratic. Well, y'all can't see that. All right. That one I would factor. I would set it equal to 0, and I would factor it. And it will factor as x plus 1, x plus 3. All right. So that is the factored form of that polynomial. X plus 1 times x plus 3, right? Now, if I wanted the zeros, what I have to do is I have to set each factor equal to 0. And then what I do is I solve it for x. So I subtract 1, I get x equals negative 1. Here I would subtract 3, x equals negative 3. So what we have to understand is the 0 of negative 1. So this graph crosses the x-axis at negative 1. It also crosses the x-axis at negative 3. But the 0 of negative 1 came from the factor x plus 1, right? I would move it back over to the side of the x to find the factor it came from. Same thing here. X equals negative 3 came from the factor of x plus 3. Okay, so as we work through some of this, this is important that we understand. Now, this one, I can't factor it, so let's plug it into the quadratic formula. So x is going to equal negative b, so that's going to be negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times 2, over 2 times 1, which is 2. Then I've got to simplify this down. What is 36 minus, that's 36 minus 8, which is what, 28? Now, here's one thing you've got to be able to remember how to simplify square roots, right? Any perfect square factors have to come out of the root. We have to take the square root of any perfect square factors. Does 28 have any perfect square factors? Yes, it is 4 times 7. Does everybody agree with that? So this is going to be negative 6 plus or minus. Now, the square root of 4 is 2, and I don't know the square root of 7, so it stays square root of 7 over 2. Then I need to simplify that fraction. If there's something that will go into all those coefficients, the negative 6, the 2 by the square root of 7, and the 2 on bottom, I need to be able to simplify that fraction by that factor, which 2 goes into all three of those. So when I divide 2 into all of those, I end up with negative 3 plus or minus the square root of 7, all that over 1, and I'm not going to list it as over 1. So that is my two zeros. Everybody agree that is equal to two separate numbers, right? Negative 3 plus the square root of 7, negative 3 minus the square root of 7. So that's where I'm getting my zeros up here. -3 plus the square root of 7, -3 minus the square root of 7. Okay, so that's the first thing it's asking for here are my zeros. All right, now the next part's a little bit more confusing, and I wouldn't even write it the way I wrote it in here. I'm going to show you a different way to write that. Is it wants to know the polynomial that this came from, or this polynomial up here. It wants us to basically factor it over complex numbers. Okay, we want to factor it using our imaginaries. Well, remember over here where our x equals -1 came from x plus 1, because that's a -1. The zero of -3 came from x plus 3. Well, here are my two zeros. Let me see if I can slide that down and get some more room to write. Well, that doesn't really work like that. All right, so my two zeros are -3 plus the square root of 7, x equals, and x equals, oh, sorry. -3 minus the square root of 7. Is everybody okay with that? That those are my two zeros. So what I'm going to do, if I look at that complex number, -3 plus the square root of 7, that's like a positive number. Okay? If I look at it in its entirety. So what I can do to get this equal to 0 is I would subtract that complex number from both sides. Same thing here. I would subtract that complex number. And this now becomes my two factors. And that's what they want in the second part. Okay, that is now factored over my complex numbers. Or this is actually factored over irrationals, because this is not a complex number. This is now factored over irrationals. Okay? X minus that complex number, x minus the second zero. So basically, your zeros, whatever your zeros are, you can subtract them from x to get the factor. Does that make sense? Just like in that easy one, over there, when my 0 was -1, if I say x minus that 0, x minus -1, that's the factor. Simplifies to x plus 1. My 0 is -3. I subtract that from x. X minus a -3 turns to x plus 3. Okay? So to find my factors, I simply take the 0 and subtract it from x. Okay? So let's move on to another problem. Sure.
How do you put that into the thing though?
As your answer?
Yeah.
Just like this right here?
Like, is there a space in between the?
No, you would have to, you got to be careful with your parentheses, but this whole thing is going in there right there that you can't see now. You just got to be careful because you got to have the parentheses around the entire thing, and then you want the parentheses around the complex or the irrational number there. All right. All right. Let me move on to another problem. Oh, there it is. All right. This one, and let me do this. Look, Well, this one doesn't have an extra answer. All right, so what we have here, so you can see it, is f of x. Let me change the color of my pen. Equals x squared plus 9. All right. So in factored form, so what we have to remember, difference of squares now, the pattern of difference of squares, if it is a real number, it will only factor. If we're only doing it over reals, if it's a perfect square minus a perfect square. Well, this is a perfect square plus a perfect square, which if we factor it over complex, we can factor that to x plus 3i, x minus 3i, right? Because when we multiply 3i times negative 3i, that's negative 9i squared. I squared turns into negative, turns it into a plus. Okay? So this is my factored form, and then if I wanted to solve for the zeros, I would set each one equal to 0. And to get x by itself, I would simply subtract 3i, right? And x minus 3i equals 0. I would add 3i, x equals 3i. Okay? So that's what's going on with that one. Any questions? All right. All right, this one. This is f of y equals 81y4 minus 256. And it says find all the zeros. Well, when we're looking for zeros, our first option is always going to be to see if we can factor it. Or I guess it doesn't always. It could be to look at the graph. All right. But I like to start with factoring because if I can factor it all the way down, then I've got my zeros right there. And the graph, if it's an irrational number, you're not going to be able to pull the zero from the graph. If it's an imaginary, you can't pull it up from the graph. So two terms, I'll always look to see if it will factor by difference of squares. And this is a difference of two squares. So its first step in factoring is going to be 9y squared minus, what's the square root of 256? Is that 16? Square root of 256 is 16. So it would be 9y squared minus 16, 9y squared plus 16. So if I were factoring this only over reals, now I could only factor the left side. But we want to completely factor. We're finding all of them. So whenever we're finding all my zeros, I'm going to factor over complex numbers too. So 9y squared minus 16 is another perfect square, difference of squares. So that's going to be 3y plus 4, 3y minus 4. Then this one, because it's a plus, turns it into 3y plus 4i, 3y minus 4i. So whenever it's a plus, it factors just like a difference of squares, except the second number is imaginary. You put the I with it. So those are my four factors. So the second part there, where it asks me to write the polynomial as a product of linear factors, that's it right there. Okay? Now for my zeros, right, what do? We take each one of those and set it equal to 0 and solve. So 3y, I would subtract 4, then divide by 3, and I get y equals negative 4/3. Now notice, the fraction, the 0, -4/3, did not come from y plus 4/5. We'll have to use this later. Okay? What you want to do is you've got to get rid of the denominator first by multiplying. Then you could subtract the number that's there. So I've got to multiply it. If I want to go from that 0 back, a fractional 0 back to its factor, I multiply by the denominator, and then I subtract the numerator. So when I divide or multiply by that, it's 3y. Then I subtract -4, which would mean 3y plus 4, and that's where it came from, as you can see. So as we're going to do that, if we do that one, we're going to get a positive 4/3. If I do that, this one, then this is going to be a -4i/3, 4i over 3, and then that's going to come from a positive 4i over 3. All right, so that's my zeros from there. So that problem, what number is that? Number 7. And then number 8's the next problem is probably the hardest problem on the assignment. So we'll spend a little time on it. Huh? No. 8 is you got to pull back several things, and we didn't really specifically say what you got to pull from, but you got to pull back from some other things. All right, any questions there? Hopefully this is helping. All right. Now let's go to problem 8. All right, so here it is, f of s. So be careful too, whenever they use f of s instead of x, that you don't put x's in your answer. I wish they would just use x's all the time, because s's look too much like 5s for me. All right. Well, this isn't the one that gave us. Okay, so let's look at this one. This is actually not the one I thought was the hardest, but this one's still fairly difficult. All right, it wants us to find all the zeros. So my first option is to look at factoring. Well, this is not going to factor. 4 terms is not going to factor. All right. If I can't factor it, my second option is going to be to look at the graph and see if I can find 1 or 2 or 3 zeros off of my graph. Okay. So let me write this down. This is, well, let me just, no. 6s3 minus 7s squared plus 32s plus 35. Now watch how we're going to do this. I'm going to pull up my calculator. All right, I'm going to go to my y equals. Oh, it leaves that on there. And I'm going to type that in, 6, and then I'm just have to use x on my calculator. 6x to the third minus 7x squared. I'm going to have to clear this drawing because it's in my way. I can't even see what I'm doing. X. Plus 32s plus 35. And I'm going to look at the graph. All right, look, that graph, it crosses the x-axis at almost -1. All right. So what I'm going to do is I'm going to use the zero function on my calculator to see if I can get that 0. All right. That's just one place. That's one real 0. And it's an x cubed function. So we know there's 3 zeros, and that's one of them. So what I'm going to do is I'm going to hit second trace. And you see number 2 there, 0. I'm going to hit 0. And then what I've got to do is I've got to pick a point to the left If it'll show up, my little blink. I've got to get it close to -1 on the X value to get it to show up. There it is. And probably what I need to do is I need to zoom out of this. Zoom 3. Let me hit second trace 0 again. Why won't this zoom? Let me go zoom standard, zoom 6. There we go. Now maybe when I hit second trace, I can find my. All right, there's my X. I got to get on the left side, I hit enter. And then I've got to get it on the other side and hit enter. And I hit enter again. And notice it tells me my 0 is at -0.83 repeating. Now, a repeating number doesn't do me any good because I'm going to have to round that off. So what I need to do is change that to a fraction. So watch this. -0.833333333. And then if I hit alpha y, notice that bottom one there, fraction to a fraction to a decimal, decimal to a fraction. I'm going to hit 4 and hit enter, and that is the fraction -5/6. So I have found one of the zeros. Okay? So let me go back. Where we at? Right here. So let me go back to my f. Whoops. I've got to put f of x s is 6s3 minus 7s2 plus 32s plus 35. I have one of my zeros is -5/6. Now, here's the problem. How can I use the fact that I know one of my zeros? I know now I have 2 zeros left. 2 zeros come from a quadratic. So if I can get this into a quadratic form, I can either use my quadratic formula or I can factor it. Well, here's what we have to do. First off is we have to figure what factor did -5/6 come from. Well, remember what we just did? We multiplied by the denominator and then subtracted the numerator to find the factor. So if I multiply by 6, that's 6x equals -5, and then I subtract -5, which means 6x plus 5. So can everybody see that the answer, the 0 -5/6, comes from the factor 6x plus 5? So that is one factor of that polynomial. There's 2 more factors because we know it's a degree 3. There's three zeros. And I used x. I need to change that to a s because they're using s in this problem. So what I'm going to do is I'm going to take and I'm going to divide that factor out of this degree 3 polynomial. And it is a factor, so I know my remainder is going to be 0. So here we go. 6s times what would give me 6s3? S squared. 6s times s squared is 6s3. So this is where this long division we did in the last part comes into play. And then 5 times s squared is a positive 5s squared. Now I've got to subtract it, right? So I change the signs. That adds to 0. This is going to be -12s squared plus 32s. 6s times negative 2s would give me negative 12s squared, right? So that's negative 12s squared. And then negative 2s times 5 would be negative 10s. Change the signs to subtract. That adds to 0. That is 42s plus 35. Well, 6 times 7 would give me 42s. 6s times 7. And then notice what happens. That's 42s plus 35. So I have a remainder of 0. So what I have is 6s plus 5 times s squared minus 2s plus 7 equals our polynomial. Here's the quadratic that I'm left with. Now, they want it completely factored over irrationals and complex numbers. So I need to find the factors of this part. Can I factor it? Well, factors of 7 add to negative 2. The answer is no. So what I've got to do to find my other two zeros is I've got to use my quadratic formula. So negative b, so that's going to be 2 plus or minus the square root of negative 2 squared is 4 minus 4 times a, which is 1, times c, which is 7, over 2 times 1, which is 2 plus or minus the square root of negative 24 over 2. All right, now I've got to erase some of this long division so I have room to write. So now it's just a matter of simplifying this fraction. I need to simplify the square root of negative 24. That is negative 1 times 4 times 6. Does everybody agree with that? All right, the square root of 4 is 2. The square root of negative 1 is I. That's our imaginary number. And then I don't know the square root of 6. And then that's all over 2. And then what we did earlier is if there's a common factor between all three terms, I've got to simplify that fraction. And 2 will go into all of them. So when I simplify out 2, I am left with 1 plus or minus I square root of 6 over 1. That is my other two zeros. So let me erase this so I have somewhere to write. My three zeros are x equals negative 5, 6, x equals 1 plus I square root of 6. The 1 plus? Yes, you do have to put that one because it's not a coefficient. And then 1 minus I square root of 6. And you'll notice sometimes in the book and on this, they'll put the I after the square root of 6, but to me it gets confused whether it's inside the square root or not. So that's this part. That's my zeros right here. Okay, now let me erase this down here. The second part is what is the multiplication or the product of factors. So basically he wants us to multiply the three factors, put it in completely factored form. Well, we've already said, and I need to change these to S's or else I'm going to miss it. So we've already said this comes from I multiply by 6. So that will be 6s, and then subtract that number, -5, would mean that's 6 plus 5. This one is going to be, there's that complex number. It's simply going to be s minus that complex number. Don't forget your I like I almost did there. And then the last one is going to be s minus this complex number, 1 minus I square root of 6. So that is the product of factors. Now, obviously, on y'all's problem on the WebAssign, we'll have some different numbers, but it's worked that way. So these are fairly complex problems here. But once you get the pattern of what we're trying to do, right, we always look to factor first. If we can factor first to get to my zeros, that's good. If I can't factor, then I'm going to look at my graph to look for real zeros. And then I'm going to find that factor and I'm going to divide it out so that I can find my other factors, get it down to a quadratic. All right. Okay. Let's look at another question. What's this one? All right, so this one's very similar. Okay, very similar. Let me write it out. This is f of x. So we can see it, x to the fourth. So how many zeros do we have? We're going to have 4 zeros. All right, so what I'm going to do is I'm not going to be able to factor that. So I'm going to look at my calculator. And I'm going to put that in there if I can see that. That is x to the fourth. What is that? Minus 12x cubed, 12x cubed. Plus 37x squared. Whoops. Can't do it up there. Minus 12x plus 36. All right, I'm going to look at the graph and I'm going to look to see if there's any real zeros. Okay, so look at what that does. That is a parabola looking shape, and it comes down and then it hits what? X equals 6 and then bounces back up. Here's what we have to remember about repeated zeros. Whenever a graph hits the x-axis and bounces back the other direction, that represents 2 zeros at that point. It represents a repeated zero. So my repeated zero is, I know x equals 6 2 times, which means the two factors, that two of my factors are x minus 6 and x minus 6. It's a zero with a multiplicity of 2. There's 2 zeros at 6. That's what happens when it bounces back at the bottom or the top of a parabola, or a parabola looking thing here. So that's 2 of my 4 zeros right there. All right. So what I've got to do from there is I've got to divide those two factors out of my polynomial so that I can get down to a quadratic. Well, I'm not going to divide it. You could divide x minus 6 and then do it again, but what I'm going to do is I'm going to go ahead and multiply this into one polynomial. So that's going to be x squared, and then that's going to be minus 6x, so that's minus 12x. And then negative 6 times negative 6 is positive 36. And then I'm going to divide that into my polynomial, my original polynomial. All right, and let me see if I can pull up that other page so it's a little clearer to see. All right, so now x squared times what is x to the fourth? That is x squared. That's x to the fourth minus 12x3 plus 36x squared. Notice when I change signs, both of these add to 0. That's fine. Less work. I'm left with x squared minus 12x plus 36, which is exactly what I have right there. That means this is going to go into it one time. I should always get a remainder of 0 when I'm dividing out a factor. So I have x minus 6, x minus 6, and x squared plus 1. How can I factor x squared plus 1? That's going to be x plus I, x minus I, right? The square root of negative 1, that's an x plus 1, so that factors as an imaginary factors. And there are my four factors. So that is going to be the polynomial as a product of factors. And then what does that mean my zeros are? Well, this one will be 6, 6 again. Then this would be negative I. This one would be positive I. There are my four factors. And then it asks you to list all the x-intercepts, which is the same as the 0, except the real. Imaginaries don't have an x-intercept, only the real numbers. Okay, so the process to this, once again, factor, see if we can factor. If we can't factor, go to our calculator and find real zeros. When we find the real zeros, put them in factor form, and then factor that out of the original polynomial. And then once you get a new polynomial, either factor it or use quadratic formula to get all the factors of what we're looking at. Okay? All right. Let's clear that out. I want to get to the one that has the A in it, because that's the one that's... All right, here it is. This is the problem. This is the one I think is the one that's the most difficult. But it says a polynomial function f of x with real coefficients has the given's degree, zeros, and solution point. It says it's degree 4. So how many zeros does it have? 4. Well, it tells us the zeros are x equals -1, 3, and I. There's one more 0. We know it has to be negative I because imaginary zeros always are in pairs. If you have one, you're never going to have just one imaginary 0. You got to have them in pairs. The conjugate of I is negative I. Okay? So it says write the function in complete factored form. Now here's the kicker on this one. They tell us that there is a solution point of f of 1 equals 16. All right. Now, the reason they're putting this on there, if I just looked at the parent function f of x equals x squared, that would be just a regular quadratic, a parabola that has a x or a 0, 2 zeros at 0, right? Well, if I were to multiply that by a coefficient, it's still going to be, the zeros are going to be the same. It's just, it's going to look different. It's going to be much more narrow. Okay? So that's what they're telling you, is they're telling you that this point is on the graph. So what number has been multiplied out front of the polynomial to make it go through that point is what it's saying. Let me get this all out of the way. So here's what we do is we're going to have our polynomial is there's going to be an a out in front that we don't know what it is yet. And then we have the 4 zeros, and we need to list the 4 factors that these zeros come from. Well, it comes from x plus 1, x minus 3, x minus I, and x plus I. All right. So right here, they're wanting you to write the function in completely factored form. Before I can do that, I have to calculate what A is. Well, the way I can figure out what A is I could go ahead and put 1 in for X and set it equal to 16, because when X is 1, it tells me it's equal to 16 right here. But right here, it tells me I'm going to have to put it in a polynomial form. So it's going to be easier to do if I go ahead and multiply that all out. So I'm going to go ahead and multiply it out right now. Okay, and then I'm going to plug in the 1 and the 16. Now, so this is just going to stay A right now. That's not going anywhere. So, right, when I'm multiplying binomials, I can only multiply 2 together at a time. So I'm going to multiply the real ones together, and I'm going to multiply the imaginary ones together, and then I'll multiply those 2 together. X times x is x squared. That's going to be negative 3x plus 1x, which is negative 2x. And then 1 times negative 3 is negative 3. So that simplifies to that trinomial. This, x times x is x squared, right? Where does this come from? Ix minus ix is 0, and then negative I times I is negative I squared. What's negative I squared equal? Plus 1. All right. Now I've got to multiply this trinomial times this binomial. So this x squared has to distribute, the negative 2x has to distribute, and the negative 3. So I have x to the 4th plus x squared. Negative 2x to the 3rd minus 2x minus 3x squared minus 3. And then I'm going to combine like terms. It's going to be x to the 4th minus 2x to the 3rd, x squared minus 3x squared is negative 2x squared. X's minus 2x, and then minus 3. All right, so that's completely simplified. Now what I can do is I'm going to substitute 1 in for x, and make that equal to 16 because of this solution point. And let me get through this and then y'all can go to the bathroom. So I'm going to put 1 in for x. So that means that's going to be 1 minus 2 minus 2 minus 2 minus 3, which means 16 equals, what's that, negative 1, negative 3, negative 5, negative 8. Equals negative 8a. And then when I divide by negative 8, I get a equals negative 2. So when I go back up here to write the function in completely factored form, now I know what a is. It is negative 2. So here is the completely factored form. Right here. Negative 2 times x plus 1 times x minus 3 times x minus 1 times x plus 1. Then the function in polynomial form is this right here. That is now negative 2. Now, I can't leave it in polynomial form, means I've just got to distribute that negative 2 all the way around, so all the way through. So that's going to be f of x equals negative 2x to the fourth plus 4x3 plus 4x squared plus 4x plus 6. And that's where I get that bottom part. So that was one that we really hadn't been over anything. We have done all that, but we didn't really ever put it together. So that's how you got to get through all of that. All right. Any questions? I think that pretty much covers everything that you need in this section, but let me look and see if there's a problem that's any different. So problem 11, this is one that will factor x to the fourth. Let me just quickly, I'm not going to go through the whole thing, but x to the fourth plus 20x squared minus 125. We can factor that like a trinomial. It's going to be x squared and x squared. What will multiply to negative 125 and add to 20? That's going to be positive 25 and negative 5. And then we've got to factor it further. That's a plus, perfect square. So that's going to factor as x plus 5i, x minus 5i. And then this one, because 5's not a perfect square, we're going to factor it over rationals. That's going to be x minus the square root of 5, x plus the square root of 5. And then you can get your zeros from there, and that's the factored form. Okay? So when we start looking quadratic binomial is going to factor. All of them will factor now that we start going over rationals in complex numbers. All right. And then you can finish it up from there. Given 0, find all the zeros of the function. So this one, I'm not going to go through it. It's a cubic, or it's x to the third, so there's 3 zeros. It gives us 2i, which means we know negative 2i is also. Then I'm going to get my 2 factors from those 2, multiply them together, and divide them out, and to find my third factor so that I can set it equal to 0. 2 more questions. 13, using this exact same thing. It tells us that the 0 is 5 plus 3i. That means we know 5 minus 3i is also a 0, the conjugate. Now, what makes this one more harder is now we've got to find what factors. Of course, if you want to, you might be able to put that in the calculator and find your real answer, because there's one more 0, so we know it has to be real. If you weren't able to do that, what you would have to do is put these as factors. That would be x minus 5 plus 3i and x minus 5 minus 3i. And then you would have to multiply those out and divide it out, use long division, divide it out. But I think on this one, you can find your third 0 by just looking at your calculator, because you know it's a real 0 because there's only one more. It can't be imaginary because they always come in pairs. And then what about the last one? All right, same thing. Use the graphing utility to find the real zeros. It's a cube. So you find out that there is a 6, and then you're going to divide that one out and probably use your quadratic formula to find your two imaginary zeros. So there's a better explanation of what we're going through. So I feel better about y'all being able to get through that. I'm going to extend that assignment till the end of next class period.